So quadratics part 1, this is the day 0 notes, kind of an intro to quadratics and the difference between a function and a relation, domain and range, and a little bit of evaluating functions. Okay, so to get started, we have a relation. A relation describes a correspondence between any two quantities. And for our quantities, we're going to use what we call variables. Okay, so the domain of a relation is the input variable. Sorry. Or the x-coordinate. Most of the time, our input is our x and our output is our y. Okay, so the range of a relation is the output or the y-coordinate. Okay, so for example, I can give you some ordered pairs 1, 3, 0, 9, 1, 5. Doesn't necessarily have to have an equation for the variables. It's just a relation between numbers. And the ordered pair 3, 2. Okay, so for this relation, our input, remember that's our x-coordinate, and our output is our y-coordinate, also the domain and the range. Okay, so our input in this case is the number 1, 0, and then I come to 1 again, so I'm not going to write that down. The number 2 and the number 3. So for my output, I have 3, 9, 5, 7, and 2. So if you look at this, I'll look at this later, but you can see that the number 1 corresponds with 1 and 5. 0 goes with 9, 2 goes with 7, and 3 matches up with 2. So that's the relation between those two numbers, or those numbers. Okay, so in order for a relation to be a function, the input, or the x-coordinate, has exactly one output, which is the y-coordinate. So every value of the domain can only have one matching output from the range. So if you look at this case, this is not a function because the number 1 has 2 different matchups. It matches up with 1 and 5. So a quick definition of a function is the input or the domain or the x value cannot repeat. So for the example above, the number 1 repeats. All right, so for these, we're going to determine whether the relations are a function or not. So if I look at my input, I have -2, 1, 5, 2, and 8. And for my output, -2 is with 2, 4, 5, -2, and 4. So -2 is only matched up with one output, 2. 1 is matched up with 1, 2 is matched up, and 8 is matched up. So yes, this is a function because the x values don't repeat. Okay, so for this one, if I pull out my domain or my x values, I have 0, 3, 9. I have 0 again. so I'm not going to write it down, and 1/2. For my output, I have -5, 4, 1, 3, and 4. So 0 is matched with -5, 3 is matched up with 4, 9 is with 1, but then 0 is also matched up with 3, and 1 is matched up with 4. So no, this is not a function because 0, the input of 0, has 2 different outputs. So the value of 0 repeats. So the answer would be no for that being a function. So when you're given a graph, you can kind of see that we might have to estimate some numbers. But when x is equal to 4, I have 2 different values here. I believe that is a 2. So here we have 4, 2. And here we have 4, -2. So this is not a function. Because the x value of 4 repeats. All right, so that is just a little bit about the definition of a function. So now if we look at a graph, which we just looked at, if you see something, to see if something is not a function, we need to see if the x values are repeated or not. This allows us to have a quick and easy rule for graphs specifically. This is called the vertical line test. A lot of times I abbreviated the VLT, vertical line test. So any vertical line can only touch a graph in each x value. One point at a time. If it hits the graph more than once, then the graph is not a function. So if we go back and look at this one that we looked at before, right here, if I draw a vertical line, it passes through that graph twice. That's an easy way to look at a graph to determine if it's a function or not. Okay, so an alternative name, I already told you that above, the VLT. Okay, so we're going to use the vertical line test in these graphs to determine if they are functions. So for this one, it looks like it's going to pass it. If I draw vertical lines, they're only passing through the graph one time. Only passes through here once and once and once and once and once and once. So I would say yes, passes the VLT or the vertical line test. Okay, so for this one, this is a cube root function. Like I can draw lines, vertical lines. Right here, it appears to not pass. It appears to fail it, but it really doesn't, knowing a cube root function. There's just a bunch of points right there that are really, really, really close to the y-axis. This one is a yes, passes the VLT. Okay, so this one is a definite fail because right here, for instance, I can see that that vertical line passes through that graph twice. So this one is no, it is not a function because it fails the VLT. Oh, recording. Oh my gosh. All right, so function notation, instead of writing y equals anymore, we're going to write f of x. So when you read this, f of x, x is the input, or the domain, f of x is the output, or the range. Okay, so f of x in our world is the same as the y value. So a little note, this does not mean f times x. It's f of x. For notation purposes, I think you'll see this probably on a PFA. So you just have to understand what it means. Okay, so the name of the function is 3x minus 7. So now when we want to evaluate f of 4, all that means is we're going to substitute 4 in place of x. And we're going to evaluate it. F of 4 is equal to 12 minus 7, which is 5. So for this one, it might be a little more complicated. So g of negative 3 equals negative 3 squared. Be careful of that. Minus 4 times negative 3. So that is 9 plus 12. So g of negative 3 is equal to 18. Notice how I'm showing my work on those. For this one, h of t, so I'm going to plug in 8. I get 5 minus 8 over 2. So h of 8 is equal to 5 minus 4. H of 8 is equal to 1. Okay, so for this one, you don't have a value. You just have a different name for the variable. So instead of m of p, you're going to make p equal to t. So m of t is simply going to be t minus 2. You don't know what the value of t is. All we did there was we changed the name of the variable, which is handy when you get to some higher level math classes. All right, so what else can we evaluate? The argument of function tells us what to plug in specifically. Sometimes it's just a number, as we saw in the previous examples, but sometimes it's just another expression. In this case, kind of like I changed the p to the t in the last example, I am changing the x to a to the third. So r of a to the third is going to be equal to 2 times a to the third squared, because x is equal to a to the third, minus 5 times a to the third plus 2. So every place that I see an x, I'm plugging in a to the third. So I have an a to the third there, and I have an a to the third there. So now I simplify. R of a to the third is equal to 2 times, and this is your power of a power property. So we multiply those exponents to get a to the sixth, minus 5a to the third plus 2. And all I did was get a new expression for the original expression that was given to me, because I changed the variable to a to the third. So for this one's supposed to be a complete square root there. Kind of got chopped off. Okay, so now every place I see a t, I'm going to substitute x plus h. So I have q of t equals 5 minus 4. And here I see a t, so I have to put x plus h minus square root, and I see a t again, so x plus h. So for this one, every place I see a t, I'm putting x plus h. So I put it right here after the 4, and I put it right here underneath my radical. So now I can simplify this just a bit by distributing the 4. So I have minus 4x minus 4h minus x plus h. And that's really all I can do with that. I can't do anything with that radical x plus h at this point. So again, I just get a new expression because I substitute an expression in for a variable. All right, so this last example, you can look at a graph and you can evaluate a function as long as you understand what you're looking at. Okay, so I have 2 different functions here. One is in blue. I believe this is g of x. It's in blue. And then the one I have in red is f of x. So remember, your input for these evaluating is going to be the x coordinate. So if I want to evaluate f of 2, I'm looking at the red graph. My input is 2, so x equals 2. So I go over here to 2, and I evaluate all the way up here, and I believe that is 4. That point, f of 2, is equal to 4. This one I'm looking at my blue function, so I'm going to go over here to negative 4. It's kind of hard to see. 1, 2, 3, 4 right here. And then I'm right down here on this blue graph. So down here, I believe that's sitting at negative 2. So the coordinate of this point right here is negative 4. So g of negative 4 is equal to negative 2. Okay, so I'm going to erase what I have here so I can evaluate some more. Okay, so g of 5, looking at my g function, my blue one. So if I go over here to g of 5, which is right here, and I follow it up, that point is right there on that graph, and I believe it's sitting at 2. So g of 5 is equal to 2. So all I'm doing is finding ordered pairs. The x coordinate is given to me in the parentheses, and the y coordinate I'm pulling off the graph. So for f of 6, I'm looking at the red graph. If I look at f of 6, here's my 6, and I'm going to follow it up to right here. And I believe that's 3, 4, 5. F of 6, 1, 2, 3, 4, 5. So f of 6 is equal to 5. All right, I'm going to get rid of these numbers again. Okay, so now I have to evaluate 2 different ones, and then I'm going to add those 2 quantities together. So f of negative 3, I'm looking at the red graph. So f of negative 3, 1, 2, 3, and I believe I'm right here. So that's 1, 2, 3. So f of negative 3 is equal to 3. And if I look at my g function, g of 0 is what I need. So I'm looking at my blue function now, and g of 0 is right here. So that's 2. So 3 plus 2 is 5. G of negative 6, no, f of negative 6, yes, f of negative 6. So I'm looking at my blue function again, no, my red function. So f of negative 6 is going to be over here, 1, 2, 3, 4, 5, 6, I believe. 1, 2, 3, 4, 5, 6. I can't really tell from my graph. 1, 2, 3, 4, maybe it's here. Kind of hard to see on my example here. So we'll call f of -6, 1, 2, 3, 4, 5, 6. Yeah. Okay, so looking at it again, it is this point right here. Oops. So f of -6 is equal to 3. Okay, so g of 2, get rid of these points that I have. G of 2 is right here. If I go up, that is an open circle. So g of -2 or +2 does not exist. So it's kind of like an empty y value. So a little bit of evaluating from graphs. We can evaluate from graphs. We can evaluate from expressions, and a little bit on domain and range. So hopefully that helps you. Have a great day.